Spanning tree protocol. Huge concepts. One command. By the time we're done here, we will look at spanning tree protocol in its default state and modify it to an optimal configuration. It is kind of funny. After going through probably close to an hour, if not more, of spanning tree content, we come up to the configuration and it's one thing, which emphasizes, again, I always tell people this because a lot of people studying for exams are kind of like, oh no, I got to learn all the commands. The big thing is learn the concept. Know the concept. Know how it works. The commands you can usually figure out pretty simply if you know how it all works, right? So at this level, and when I say at this level, know that there's levels of spanning tree. And you know there's multiple versions as you get from rapid spanning tree to per VLAN rapid spanning tree to get multiple spanning tree. There's multiple ways of configuring spanning tree, but at this level, and I would say at what most network administrators need, it's the ability to influence the one thing that matters most. Do you remember what it is? What's the one thing that we can really control in spanning tree? You got it. The root bridge. Who becomes the root bridge? So we need to be able to look at a network environment and say, who should be the root bridge in this environment? Then let me ask you, who do you think? And if you're looking at this network right here, who would you want to be the root bridge? I would say AZ-SW01, right? That to me looks like the most core switch of the network. Now, I would want AZ-SW02 to be what I would call the backup root bridge. That is, if this goes down, I would want this switch not to become, I want this to be the secondary because it's the core. And obviously this is a small piece of what would become a much larger network environment. So let's take a look on our switches is what is the default configuration right now? And then how do we modify it so that we can choose who the root bridge is, right? So let's do that. I'm going to bring up the console prompt, hit the enter key a couple times. I'm plugged into switch 2 right now. So I'll go into privileged mode, and here's the one show command that you need, show spanning tree. And we walked through this in a previous video, and actually we've done this discovery already in this network. Switch 2 is the root bridge. And do you remember I went through this? This is the information about who is the root. This is the information about who is this bridge, which happens to be the same as the root right now. And then here's the report of all the ports. But I'm hoping with all the hope that I have that these make a lot more sense. Like I'm looking at the root bridge right now, and all of its ports are what? Designated ports. They are ports that is forwarding, right, on each one of them. I could go down piece by piece in every single VLAN. Remember, this is running per VLAN spanning tree. So I guess that makes it two commands. One to flip it over to rapid spanning tree, and then the second command is to elect the root bridge. So let's do that. First off, hang on, I just want to give you a perspective. Let me move the console cable over. We're on switch 2 right now, and I want to go to switch number 1, right? And the reason I'm doing that is because now that you've seen the video on how the ports are elected, it will just make you feel so much better to see, oh, look, this is a non-root bridge, right? So it's saying this is who the root is, which is switch number 2. This is who I am, and then here's my port status. So I can now we should know, and we should feel comfortable with, oh, geez, 2/0/1, that's the root port. That's the way that it goes and reaches the root bridge. So we could create and label all the ports on that diagram. I think I'm just on a high because I'm just coming off of that video of like, here's how it's all elected. Here's how it figures out which ones are designated, which ones are blocked ports, right? All of those kind of things you should feel really comfortable with right now. So we're here. We're on switch number 1. How do we, first off, enable rapid spanning tree? And then secondly, how do we elect the root bridge? Well, both of those things happen from global configuration mode. Go in there and do spanning tree. I'll hit the question mark so you can see there are other options, right? We can get in, and just to give you a flyby, we can get into things like uplink fast and loop guard. These are actually Cisco proprietary things that they came out with along the way to rapid spanning tree. Before rapid spanning tree was rapid spanning tree, Cisco was like putting little tweaks in place to try and make spanning tree faster. So that's what a lot of those are, and that's why we don't cover them. Is they're just not relevant anymore because we have spanning tree mode, and you can see right there, there's our core 3 modes: rapid per VLAN spanning tree, which is the original, and then multiple spanning tree. Those are the 3 versions. Now, technically, I guess you could argue, Cisco doesn't run spanning tree. It always runs per VLAN spanning tree. They don't let you run spanning tree. The closest thing that they come to is multiple spanning tree. But the good thing is the per VLAN spanning tree is compatible with the common spanning tree, the spanning tree that all of the other switches of the world use. So even though it is a proprietary tweak, it works just fine. But this is it. Enter. Now I have to do that on every one of the switches. So give me, actually, I'll just get the video. I'm going to go to the other switches and do that same command. There we go, bring it back. And you can see that all I did was, this is where I started on switch number 1. I went to switch 2, did the same thing, and went to switch 3 and did the same thing. Move my console cable, whoops, wrong spot. I moved my console cable over. It's supposed to be on switch number 1. I'll reach behind there and move it up. There we go. I'm on switch number 1. So right now I'm going to go back and do a show spanning tree because we should see some impact. And, well, I should say the only impact that we'll see is instead of it saying spanning tree enabled protocol IEEE, which is what it said before, it now says it's using rapid spanning tree. But in order to gain those benefits, they all have to be running rapid spanning tree. So that's why I flipped them all over to rapid, right? So now, how do we get switch number 1 to be the root of the network, the core? Well, I'm going to go into global configuration mode. There's actually 2 ways that I can do it. I'm going to type in spanning tree, and it's going to come up and say, well, you've got, all backbone, all these different things. Because we're using per VLAN spanning tree, we have to designate the VLANs. So I'm going to say the spanning tree for VLAN, and that's where I would say for 1, 10, 20, 30, 40, which is all the VLANs that we have on the switch. I'll hit the question mark, and it says you can either type in root, which is really easy. And what it will do, that's kind of like a dynamic command. What it does is it goes out and discovers the network. It says, what other switches are running on the network? What are their priority? And I'm going to take my priority and make it less than those. Right? That's kind of a safe bet to do, but feels kind of automagical in my opinion. So what I like to do, so by the way, you can type in root and you can say whether you want it to be the primary or the secondary. So the primary will set itself at kind of the low value, right? The secondary will set itself 1 level above that. Now, what I like doing, instead of using the root command, is use the priority. This is the second way you can do it. This is where you manually type in your priority. Now, it's a little tricky because you see right here it says, enter the priority, what's that say? In increments of 4,096. What? Why? You might remember, I told you earlier, but it probably was gobbledygook back then because we were all still learning spanning tree for the first time. I said when Cisco tweaked spanning tree, they took these bits, they stole them from the priority. So spanning tree, you've seen those protocol headers, right? Where they're like, this is the IP header, it's got this source IP, and it's got the breakdown of everything that's inside of a protocol. Well, spanning tree has the same exact thing, right? But what Cisco did is they said, okay, there's a field in there that's priority. And that field actually has 16 bits allocated, which is why it can go to it actually technically goes to 65,536, right? You can get that many priority levels. They said, you're not going to need that many priority levels ever in the spanning tree world. I can't imagine you needing more than, I don't know, 3, 4 different. I mean, how many priorities do you really need when you're setting the bridge ID? So what Cisco said is, let's do this. We're going to steal some of those bits and use them to add the VLAN number. So now when the BPDUs go out on Cisco switches, it actually goes out with the priority. It says, here's my switch ID, all that kind of stuff. But it actually has the priority, or I should say the bridge ID, the priority, and the VLAN number. And that's how Cisco can run spanning tree on every single VLAN, is they stole those bits. But by stealing the bits, you're like, well, where's this all going? By stealing the bits, they said, okay, you're only allowed to use priorities in increments of 4,096 because we don't have all 16 bits left. So we're just going to, let you use 4,096 or 8,100 and something. So that's the problem, is you're looking here like, I don't know. So I'll just do 3. And it comes up and it'll actually tell you in the error message, it says, oh, by the way, the allowed values are, right? There's your priorities. So if I'm all in, I'm electing the root bridge. I'm going to say 4,096 or even 0 if I want to go like nobody's ever overcoming this root bridge. And by the way, it is a security risk to have another user come in and try and become the root bridge of the network. That's why they have, when you get into the security world, they have features that if somebody comes in and says, I'm the new root bridge, and it's not on one of your trusted connections, it will automatically disable the port. So that's what, if you want to get into the security sides of things, those are out there. But in this case, I'm just going to say this is 4,096. Now, watch. It was very fast. Very fast. Show spanning tree. I hit the enter key, and look at that. Bam! I am now the root bridge. I have all designated ports. Look at my priority, 4,097. Again, do you remember this? It's because it adds the VLAN number, that system ID extension, we're on this for VLAN 1, to that priority. So now it says my final priority is 4,097, which is going to be way lower than all the other priorities out there. So we become that spanning tree root for every single one of the VLANs that exist. So on our smaller topology, it should become a lot easier. This guy is now the root bridge, right? Let's do the same exercise we did in a previous video. He has all designated ports. We know that out of the box. So which of these ports is the best one to get to the root bridge? Well, we'd look and we go, okay, well, we got a tie. Remember, we go with cost being the first one, the lower bridge ID being the second one, and now we can actually use the port, that final tiebreaker. We go, okay, lower port value is preferred, so that will become the root port. And then over here we'll come to this switch. We look, we go, okay, well, we can go that way, and it's a cost of, it'll actually be a cost of 19 because that's a 100 megabit per second link. These are the cost of 4, right? So cost of 19 or a cost of 19 plus 4. So it's going to say this is my root port, right? Going to a designated port, and then we look and we block everything else left over. So we have to fill in. Okay, this guy's a designated port because he has the one designated port per link. So this guy ends up blocking, right? Because we've got designated port over there. Block. This guy designated. Okay, this one can't be designated. It's not the root port, so block, right? So let's see if we pass. So now I know it's smaller than the topology we did in the previous video, but let's see if that's what we ended up with. So we'll go here. And let me move my console cable over to switch number 2. Reaching back. Snap. We're in. All right. So I'm going to do a show spanning tree. Right? So we've got, it's recognizing the root ID. That's the new root. It says, this is me. I'm this person. So this one right here is gig 1/0/1. That is the root. Did we pass? Yes. Right there, gig 1/0/1. That is the root port, okay? Gig 1/0/2, that is a blocked port. Did we pass? Yes, we said that's going to be a blocked port right there. All right, fast Ethernet 1/0/2 is designated. Same thing with 1/0/3. Did we pass? Yep, and by the way, I don't know if you remember, I said if you plug in a computer, you're going to get a designated port because the rule is one designated port per segment. So they'll all be designated, right? So good. We passed with flying colors on AZ switch 02. Moving my console cable up to AZ switch 03. Let's check it out. Here we go. Hang on. So if we're right, fast Ethernet 0/1 should be the root, and fast Ethernet 0/2 should be blocked. Let's find out. I'm up there. Oh, there we go. Show spanning tree. Hit the enter key. Again, recognizing the new root bridge. Fast Ethernet 0/1 root. Fast Ethernet 0/2 is a blocked port. Come on. Do you get it? Do you get spanning tree? I hope so. If you did, you're way ahead of where I was when I first got into Cisco. It literally took me months to really go, okay, I get spanning tree, just because it's something that you just have to immerse yourself in time and time again. As a matter of fact, right now, I'm doing study sessions. So right now, I'm recording the CCNA 2020. But there's a mass amount of people trying to get the old CCNA because it's going to expire in February of 2020. So I'm doing study sessions for those people on the side. The number one requested topic, you guessed it, spanning tree. Everybody wants to know, how does spanning tree work? After that, it's actually subnetting. Spanning tree is beating subnetting in the amount of requests for how many people are confused on this. So if you need some more time, take it, please. Run back through these videos. Feel good about spanning tree. I know that you will. We've looked at Spanning Tree in its default state and modified it using our configuration commands to an optimal configuration. I hope this has been informative for you, and I'd like to thank you for viewing.